Types in programming is sort of a strange thing. There is such a thing as types, but we'll have to get into what those are in a different video. Today I'm talking about storage types. A lot of people sort of misunderstand the idea between storage types and actual types. If you want me to do a video on that, I'll have to do that in a different day. Today we're just discovering what an int is. What is a storage type? What is a type in most programming languages, as well as just how computers understand types. So let's actually just get started with this very simply. We're just going to have a u-byte array of 4. We're just going to call that x. We're going to have our new x, which is going to be our int here. And we're just going to say that x is equal to 1, 0, 0, 0. And we're going to say that our new x is equal to, in this case, this is where we're going to get something a little bit strange. We're going to take our x here, and we're going to cast it to a int pointer. This is a little bit strange, but it'll make sense in a moment. Now we're just going to dereference this pointer to get basically the first element out of it. And if I actually take this and I run it now, number one, I don't have a print statement, so nothing's actually going to happen. Let me just print this out real quick. There we go. So now when I run this, what we're going to get is our 1, 0, 0, 0, and 1. Interestingly enough, this doesn't exactly do what you would expect. Obviously, if we do 255 here, we're going to get 255. Pretty much what you would expect. If I put this one number over, we're going to get 256. That is a little bit different than what you might expect at first. If I put it one more over, we're going to get 65,000. And then if I do one over again, we're actually going to get 16 million or something like that, as you can see right here. Now, again, basically, this is an array of bytes. Now, if I actually set this over 256, you'll see that it is an array of bytes. We can actually go over 255 here. So it's 0 to 255. So we can, like I said, put 255 here. Now, what we're doing is we're casting this, basically this pointer. Granted, let's just make sure it's very explicit. So this also works. For example, this is just a pointer. And again, this also works because if we get the first element out of our array, this works the exact same way, because what we're doing is we're getting the location of our first byte. And when we cast it to an int pointer, when we dereference it, it's going to grab all 4 bytes, because this is a common sort of concept that most people understand. An int is 32 bits, or an int is also known as 4 bytes. Most people understand that an int is 4 bytes or an int is 32 bits. But people tend to think that like an int is special. It's really not. We can do the exact same thing with a short here. So if I take this and convert it to a short pointer like so, and then rerun it, we're going to get the exact same results again. So if I do this, we're getting the exact same result that you might expect. We're just getting 255. If I set this to 1, we'll get 65,000. Now, interestingly enough, if I move this, we're going to get 1 again. So as you can see here, boom, we just got 1 because I moved this one over. Now, if I actually go to this position, right, we're actually going to get 256 again. Now, if I set this to 2, we're going to get 512. And that is because our short pointer is pointing at this location right here, and it's grabbing the 2 bytes, which is our first byte and then our second byte. So it's just one of those things that is sort of interesting that people tend to sort of not understand properly, that an integer is literally 4 bytes. It's not figurative, it is literally 4 bytes. Now, the next thing I'm going to do is sort of do this in reverse real quick, where we're going to take our new sort of value here. We're going to set this equal to 512, just so we know exactly what the value is supposed to be, which will be 0200. And we're going to set our new x, basically is going to be, or actually, I guess we'll call it new v, is going to be equal to, I guess, a u-byte array of 4 here. We could set this obviously to a short if we really wanted to by just doing an array of 2 bytes. Actually, let's just do this as an array of 2 bytes. It's really not that different from anything else. And we're going to get a pointer to the thing that we need here, which is our v. So we get the pointer, and we're going to cast this to a u-byte array of 2 pointer. So we have this. So now we have a pointer to that location, but then now we need to dereference it. So we have a pointer to our v here, which is our 512. So that's this. We're casting it to a u-byte array pointer of 2, and we're going to dereference that. Now, if I rerun this, number one, I do need to do this. So we have in v. This is our new value here, and we have a 02. Now, if I actually did this as a v, what we'll see here is that we have 512 and v there. Now, obviously, I could have used this x or nx or whatever else, and that would work basically the same. Actually, I do need to reset this there because I was actually going out of bounds, which is sort of funny. It's very easy to accidentally go out of bounds when doing these kinds of things. That's why it's considered unsafe. So like in this programming language, you're actually not allowed to do this kind of stuff in safe code because it's obviously really not, it's not a good idea in a lot of situations. I like doing it because it's is fun and a pretty simple way of doing these kinds of things. But again, this is for ints, it's for shorts, it's for longs, it's for basically any sort of base type. But no, it's not. It's actually for any type. So if we go to a position here and do this exact same thing, we have a u byte. We're just going to have a u byte, not an array of 4, but we're going to have our r here. And we're just going to paste this through. We have r, g, b, and we're also going to have a here. So if we take this and we define a position, let's actually just delete this old code right here. Actually, if you want to copy it and try it out in C or whatever else, then you can just go ahead and do that. Anyway, and now I'm going to delete this because you don't need it right now. We're going to set this to be a pos p, and we're going to set this equal to, first, I guess what we're going to want to do is sort of do, I guess, an array of 4 bytes. So we're going to do 1, 2, 3, 4. We're going to do a u byte array of 4 here. So this is our new x that we're doing. And then we're going to cast this. We're going to cast this thing here to a pos pointer like so. And then we're going to dereference it. And we basically get what you might expect. So we're going to railin rp here, just like so. So now whenever we run it, we should get what we expect, which is 1, 2, 3, 4 out of our position. So this struct, we just cast a byte array to a struct. Now, obviously, what we can do is do another u byte array of 4, and we can say it's our new x, and we're just going to set this equal basically to the same thing again. We're going to take the address of our p here, and we're going to, in this case, cast it to a u byte array of 4, and we're this is obviously u byte array pointer, and then we're going to dereference it again. And now whenever we take this and we print it out, so we have our new x here, whenever we print this out, we're going to pretty much get what you might expect. We're going to get 1, 2, 3, 4. So we're taking our position here, we're getting the address of it, we're setting that address to be the pointer type to be a u byte array pointer, and then we're dereferencing that location. So we're just grabbing basically those 4 bytes and setting them to our nx. And whenever we print that out, we're going to get basically this. So we can actually convert a position struct from a byte array to a position, or from a position to a byte array. Now, you might think, oh, this is only for types. This would never be how code works. Now, unfortunately, I don't have the example for that set up. That would take me a little bit to set up. But yes, you can actually convert an array of bytes to a function pointer. That is something you can do. Now you have to do a memory map and set the memory type to be executable. It's a little bit more of a low-level functionality that people don't normally do. It's sort of basically how like JITs work. You could make a JIT doing this, and you take those bytes, set them, like I said, to be executable, take a pointer to those bytes, set them to be a function pointer, and you can run the code. So yeah, it does just work this way, whether it be code, whether it be data, whether it be structs, everything, strings, yeah, like I said, strings, characters, just basically everything is a bunch of bytes, and that is it. You might think that everything's bits, but actually computers fundamentally work with bytes more these days than they do with bits. Bytes are basically the fundamental building blocks. In a lot of cases, actually, bytes aren't necessarily even super fundamental. A lot of stuff just works on ints, or in this case with SIMD, it works on arrays of things. So there's a lot of stuff like this in modern computers where data structures can be sort of larger than you would expect, but also smaller than you would expect. Like an integer isn't special, it's an array of bytes. You know, a byte array isn't necessarily special, it's an array of bytes, right? It's just a pointer to that position. So there's a lot of stuff like this that is super surprising. But anyway, hopefully this helps you understand what byte arrays are, what integers are, that they are all completely interchangeable and basically the exact same thing. So when you see an array of characters is an array of bytes. They are identical. It just depends on how you want to interpret them. If you have an array of integers, an array of integers is also an array of bytes. An array of longs is also an array of bytes. An array of structs is also an array of bytes. An array of anything is an array of bytes. Everything is just bytes underneath the hood. Anyway, there's a lot of examples of this. There's a lot of things that we could explore with this. If you want me to do some more examples of this, like the one with the function pointer, so we might take some assembly code, compile it down to just some bytes, and then just cast that to a function pointer. If you want me to do that in a video, then comment down below if you want me to do that. Anyway, if you want to check me out on Twitch, the link will be there in the description. Anyway, have a great, wonderful, sublime day. See you next time.